Hello, everyone. Finally, the end is here. So let me go over the last homework 9. Scores were actually pretty good, about a B median average. Um, so for the first problem, you pay off a loan, 175,000, at an effective annual interest rate of 6% by making interest payments at the end of each year and paying off the principal in one lump sum at the end of 30 years. So a very typical sinking fund method um, problem. That exactly is what a sinking fund. What this is exactly what the sinking fund method is. It's not just one formula. It's just a method of paying off a loan by just making interest payments, but making payments, additional payments into an account where the accumulated value pays off the principal at the very end. Again, you're paying interest at the end of each year. Okay. All right, so you accumulate the 175,000, the principal that you need to pay off after 30 years by making deposits at the end of each year into the sinking fund, earning 7%. So the total yearly outlay, which is sinking fund payments plus your interest payments, is 1.5x for each year for the first 10 years and 1.25x for the next 20 years. Find x. Okay. So, yeah, you could probably get away with not really understanding what's going on here and just duplicating what I did in the example problem. And I think this might have been a quiz problem for 2021. But it's good to understand what's going on. Okay, so I'll get to that in a second. So what the time diagram I'm going to draw here is going to be deposits into my sinking fund. So let's mark that. Deposits into sinking fund. Okay. All right. So for the first 10 years, total outlay is 1.5x. So you owe interest at the end of each year on $175,000. You never ever touch this principal here. Okay. So I don't have room here. Well, I'll do it up here. I'll just do it up here. So interest payments, the end of each year, is just 6% times or 0.06 times 175,000. 175.06. So that is going to be 10,500. Okay, so this 10,500 goes towards interest. So if the total outlay is 1.5x, then you have 1.5x minus 10,500 left to put towards your sinking fund. That makes perfect sense. So it's always a challenge to fit this on the time diagram. Anyway, and why does this make sense? Well, because what's the total outlay now for the first 10 years at the end of each year? Well, you have 1.5x minus 10,500 goes towards the sinking fund at the end of each year. Then you have 10,500 interest. So add them up, you get 1.5x. That's your total outlay for the first 10 years. Okay. All right. So same kind of logic. Usually I do 29. I'll do 29, but I'm not gonna have room to put anything for 29. So it's 1.25x minus 10,500 for the next 20 years. So a lot of people made the same odd mistake that I'll get to in a second. Okay, so you need 175,000 at the end of 30 years. So that's Let's accumulate value of this time diagram. So for the first, it's just 7% for all 30 years. Okay. So you have a payment change at t equals 10. So we're going to take the accumulated value, first 10 payments. So it's going to be S10 at 7%. But then this amount sits in the account for 20 years. 10 to 30 is 20. A lot of people had it as 10 years for some odd reason. So it just sits in the account for 20 years at 7%. So time 1.07 to the 20th times this whole thing here. And then you have, I'll put it here. Then you have the 20 payments of 1.25 x minus 10,500. Okay, so this is going to be 53. So one person had had this and then had a question mark. All you do is just, if anything, you don't want to use a calculator, just plug into your formulas for S10.07 and S20.07 and just solve for x. It's 53.46529 times 1.5x minus 10,500 plus 40.499, sorry, 40.995 49 995 49 1.25x minus 10,500. Just in case you want to know what these numbers are. Second. Okay, so yeah, basically all we do here is just solve for x. Bear with me a second. Never understand why colors change and when they change on this, but anyway. All right, so you get x is 8877.19. Yeah, so it's I have to admit, it's a bit silly for me to even go over the quote unquote sinking fund formula that I did in video, because it's so often that just doesn't apply. So I think when I teach this in the future, I'm not even going to go over that formula. I just don't think it's worth it. It's, for some problems, it does make it quick, but it's just confusing because you change a little bit and change the problem a little bit, and the thing doesn't work anymore. All right. So for this next one, you pay off a 20-year, $20,000 loan at interest rate of 8%. One of two ways: the standard way of paying constant payments, P at the end of each year, or a sinking fund that earns effective annual interest rate of 7.5%. The second option, again, just like all sinking fund problems, you make interest payments at the end of each year, and you're paying off the principal in one lump sum at the end of each year. Here is specifying the payments into the sinking fund, which is used to pay off the principal of 20,000 at the end of 20 years. And it's P minus the interest on the loan each year. And the idea is that in both situations, the total outlay sorry, total outlay for each method, for each option is the same, because the total outlay for your sinking fund method is, well, you're making payments of or you're making deposits, rather, really deposits of P minus the interest on the loan at the end of each year, but then you're making payments of interest on the loan. To add the two up, it's P. For the first method, payments are P. So that's kind of the idea. They're essentially equivalent, these two methods, in the sense of you're making the same payments total at the end of each year. All right, so first thing is first, let's figure out, well, you can do one of two things first. Let's figure out what the interest payments are. The interest payments at the end of each year, 8% of 20,000 is 1,600. So it's 20,000. Okay. Yeah. So let's figure out what the payments P for the first method are. So nothing special. It's a $20,000 loan, so that's the present value. Payments are P, 20-year loan, 8%. So you just solve for P, and we get formula or calculator either way. 2,037 and 4 cents. Okay, so now we know what the payments into the sinking fund are. It's P minus your interest payments. P minus interest on the loan. Like, I really like deposits, but whatever. So at the end of each year, 2,037. Sorry, that looks a little off. So fix that. Yeah, and this is 437 04418. All right, so right, these are the deposits into the sinking fund. The sinking fund earns 7.5%. So I guess what I was saying is maybe a bit inaccurate, because at the end, it's the two methods are not exactly equivalent, in the sense that, yeah, for 20 years you're making the same payments P at the end of each year, but at the very end you have to add additional amounts, or you have a little bit extra money you need to pay off the 20,000. Let's see how much extra you need. Okay. So the accumulated value of these payments at 7.5%, remember, again, that's the point. You make payments of this 437 and 4 cents into an account earning 7.5%, and these payments are made at the end of each year. So again, really deposits. All right, so standard formula for accumulated value. Again, use calculator or formula. Use both. Good way to check it. You got plenty of time to do these problems, so yeah, check it with yeah, I would probably use formula and the calculator to check. Anyway, this is 18,926, roughly 6 cents. So I think at least one person stopped here. Well, I really did ask you for the extra needed. It's kind of not very difficult from here. So it's just 20,000 minus this 18,926, 6 cents. So it's 1,073 and 94 cents. That's how much extra you need to pay off 20,000 at the end of 20 years. Okay, number 3. So did get some funky answers here. Right. All right, Don makes a one-time investment. He purchases a 20-year, $5,000 face value bond with semi-annual coupons, 3% coupon rate and a 4% yield rate. So maybe I was a little unclear. This should be nominal. So like this is a nominal coupon rate and yield rate. Immediately after receiving his coupons, he invests coupons into an account earning 3% semi-annual interest rate. Why not? Why wouldn't you? Find how much is in the account after 20 years and find Don's nominal semi-annual yield rate for the 20-year period. Okay. Yeah, so a lot of stuff here. But let's first get the bond price, and that's the amount Don is basically investing. He's purchasing this bond, so that's his investment. What is his investment? Bond price. That's what he's paying. So you could take the present value of your coupon or coupons and the 5,000 face value. That's fine. Or just use Maycam's formula. Maycam's formula is obviously quicker. That being said, if you're an actuary major, I'm of the personal philosophy of the less you have to memorize, the better. So I do question its utility on Exam FM, but anyway, it's not Exam FM, so I think Maycam's formula is easier. All right, so let's get K in Maycam's formula. So it's a face value 5,000 times 1 over 1 plus your actual semi-annual rate, which is 4% over 2 is 0.02. 0.04 over 2 is 0.02. 40 6-month periods. And this is 2264 45208. So maybe let me move this over a bit. I think if you didn't do nominal, I only took off 2 points. But I probably should have been more clear in that. It's always a little awkward because I try to be deliberately sometimes not super clear because, well, Exam FM is not super clear all the time. So that's the point of this course. That's a little better. Okay. Yeah, and this is my K. And remember, the price is K plus R over J, 0.03 over 2, 0.04 over 2, times 5,000 face value minus K. And so we get 4316 11302. That's the bond price. Okay, so let's find out what the accumulated value of his coupons are. Gotta find out what the coupons are first. So I don't know if I don't think I mentioned this in the video, but for anyone doubting like whether this is really useful stuff like bonds, I think I actually looked up one single US Treasury bond, and it was something like I think it was like at least 20 billion with a B of that bond was purchased. A bond that works exactly like what we're doing in this problem. So, you're probably very familiar with savings bonds. They do not work this way, but when it comes to like actual like impact on our economy, they're not really that important. Um, you only can buy $10,000 each year of them. Um, the actual bond calculations and the bonds that that we're doing super important uh in finance and economics. So just in case you doubted that. Um, anyway. All right, so the coupons are 5,000 times 0.03 over 2, 0.15. So that's going to be 75. Uh, yeah, coupon rate. Okay, so accumulate value, coupons. So it's 75 S 40 coupon deposits, 40 coupon payments. Yeah, so the account, sorry, there's a lot here. The account earns 3% semi-annual nominal interest rate. So the actual 6-month interest rate is 1.5%. So it's 407009,205. Okay, so now we're almost done. So we want to figure out what Don's semi-annual equivalent nominal rate is for this investment. Okay. So, and just to kind of make sure we're all on the same page. So this investment works as follows. Don shells out 43.16 and 11 cents to purchase this bond. What does he get back? Well, he gets back the accumulated value of coupons because he deposited those to this account. And he still gets the face value from his bond. So it's 4070. Obviously, you can do this in your head. Face value is 5,000. Want to emphasize this is what he gets at the very end. 9,070,09205. Okay. Right. So, yeah, so let's say J is the actual 6-month interest rate. The equivalent effective 6-month interest rate for this investment. So what does that mean? Again, as always, this is his investment amount. And we're pretending like this investment sits in a bank account for 46-month periods, 20 years, earning this interest rate J per 6 months. What is the interest rate J if Don gets back 9,09205 after 20 years? What is it going to be? One second. I actually just wrote the answer. I did not actually get this, so just bear with me for a moment. So we have 9, 0, 7, 0. Let me move this. I don't have my this is really annoying. That 9070 09 205 divided by 4316 11302. Raise this to the 1/40. So subtract 1.018 74. So multiply by 2 to get the nominal semi-annual interest rate, I2. And we get 3.75 basically percent. 0.03748. So yeah, a lot of moving parts, but I think the idea is very important, very practical. Definitely if you're a company, you might do things like this with extra money, you might purchase a bond and then reinvest your coupons. Why the hell not? Um, so okay, last but not least, very easy make ham formula type problem. So a lot of people did it using an ADF formula. I don't even know what ADF stands for. I was lenient in what I said about not accepting formulas that we don't go over in this class. Well, lucky you guys. Next time I teach this, I'm going to be more strict because it's just a mess for me to try and figure out what people are doing when it's a formula that I don't recognize. Again, this is an actuary course. This is not a course on finance. This is not a course on banking, accounting. Everyone has their own way of doing things. Everyone has their own notation. Everyone has their own formulas. Again, by everyone, I mean banking courses, finance courses, accounting courses, actuary courses. It's probably some kind of field out there that I'm missing that does this stuff. I'm not a economics, finance, banking, whatever expert. I'm a math expert. I teach math. So math and actuary courses. So I'm just familiar with the actuary notation. That's the point of this course, to get familiar with that. But anyway, so yeah, I was very lenient on that. So easiest way is still make Ham's formula. So bond 1. Second. All right, so so all interest rates are semi-annual nominal. So yeah. So I guess I'll do it like I did before. Let's get the K. So K is your face value. F, you could set it to be 1,000. I think some people set it to be 100. I don't think it's any harder just to leave it alone and just cancel it out everywhere. But if find it easier to just set it to be something, fine, sure. It's up to you. All right, so 0.03 over 2 is 0.01 0.015. So it's 1 over 1.015, 10 years, so raise it to 20. Okay. The price is going to be K. Plus 0.04 over 2, 0.03 over 2. Face value minus K. Okay, and this is going to be, dump this into the calculator. Make sure I'm going to have room for this. 1.0858 for F. Okay, so for bond 2, F, a K is going to be, well, it's the same thing, except the yield rate is 4%, so divide by 2. I probably should be a little more clear that it's a nominal yield rate, but anyway. Okay, so again, the price. We don't know what the coupon rate is, the nominal semi-annual coupon rate, but so let's say R is the actual 6-month coupon rate. So it's K. R over the actual 6-month yield rate, 0.04 over 2. Again, F minus K. So this is just going to be 0.67297 F plus 16,35143 FR. Set the two to be equal. 1.08584 F equals. Better hurry up because my digital pad is going to run out of battery. Just have enough. 67297 F 16,35143 FR. 5. Yeah, so cancel F's everywhere. So get rid of this, get rid of this. I'll keep the R, of course, but here. All right, so you get R, very easily solve for R, 0.02525. So multiply by 2, we get the nominal semi-annual coupon rate of 0.0505. All right, well, that's it. And as I said before, if you are an economics, finance, but really any major, I would go watch after this the net present value and internal rate of return videos. they're just very useful. I have a very good discussion of those. Very important stuff in business and finance, particularly net present value. I would say more important than the formula is just the philosophy of, you know, making a decision of whether or not to go with a project or not, and understanding why people say go with a project if net present value is positive. I don't know if that's always true, but the logic is fair logic. But anyway, all right, well, so long, take care, good luck on the exam. Those will be graded tomorrow. And I'll have grades in tomorrow. So yeah. All right, take care, have a great summer, what's left of it. Enjoy the nice weather. Maybe I'll see some of you around in the fall.